You ever look at a simple picture and wonder, could there be something more to it? Like a secret message hidden right inside the pixels? Well, today we're diving deep into the incredible science of digital steganography, which is pretty much the art of hiding information in plain sight. But here's the real kicker, the big question. How do you hide that secret message inside an image so perfectly that you can pull the message back out and restore the original picture down to the very last pixel? I mean, with absolutely zero damage. Well, the answer lies in something you can think of as digital invisible ink. It's this amazing technology that lets us write secrets into images without leaving a single solitary trace behind. The official name for it is reversible data hiding, or RDH, and that word, reversible, is everything. See, most steganography leaves some kind of fingerprint, some tiny little scar on the image, but RDH, it guarantees you can get that original image back 100% flawless. It's a completely lossless process. Okay, but why does this matter so much? Well, imagine a doctor needs to embed a patient's confidential notes directly into their MRI scan. If even one pixel is off, that could lead to a misdiagnosis. Or picture an intelligence operative sending a classified photo from the field. A single altered detail could blow the whole mission. In these situations, almost perfect just doesn't cut it. It has to be perfect. For decades, though, scientists have been totally stuck. They've been facing this fundamental dilemma. You could either hide a lot of data and totally mess up the image, or hide just a tiny bit of data and keep the image looking good. You simply couldn't have both. The paper we're looking at today puts it really clearly. As the capacity embedding increases, distortion is more dramatic. In other words, the more you tried to hide, the uglier and more distorted the image got. It was this incredibly frustrating trade-off that seemed impossible to solve. All right, let's actually see this in action. Here we have a standard test image. It's a jet, nice and clean, totally crisp. It has no idea what's about to happen to it. And we're not just hiding a simple password here. We are going to embed a ton of data, like, let's say, the entire first chapter of a book, right into the pixels of this photo. And there it is. This is the Stego image, the one that's now secretly holding an entire chapter of a book. So can you spot the difference? Because I sure can't. And that's the whole point, right? A huge amount of data, completely invisible to the human eye. So how on earth does this work? It's not magic. It's just really clever math. Think about it like this. Imagine a perfectly tiled floor. If just one tile is slightly out of place, you can probably predict where it should be, right? Well, the algorithm does the exact same thing with pixels. It predicts a pixel's value based on all its neighbors. And that tiny, tiny difference between the prediction and the reality, that's the prediction error. And that's the secret hiding spot. For years, that whole capacity versus quality problem felt like a brick wall. But a brand new paper from a team led by Hung proposes this brilliant three-part solution that finally cracks the code. Their solution comes down to three key innovations that all work together. First, a much smarter way to predict pixels. Second, a better way to select where in the image to hide the data. And third, an automatic way to optimize the whole shebang for the best possible result. So first up, a smarter prediction model. See, old methods were kind of like looking through a keyhole. They only saw the pixels right next door. This new method is like having a full panoramic view. It analyzes the image's flow and texture from all directions, which means it can make incredibly accurate predictions, and better predictions mean smaller errors, which means more space to hide secrets. Next up is a real stroke of genius. The algorithm doesn't just look for places to hide data, it actively looks for places not to. It intelligently scans the entire image, figuring out the safest, most stable spots to embed the information, and carefully avoiding the risky areas. And check this out. This chart from the paper proves it. What it shows is that in really smooth areas of an image, like a clear blue sky, the chances of hiding data without causing any damage are nearly 100%. It's like finding the perfect, untouched canvas for our invisible ink. You know, think of it this way. Trying to write on a bumpy, really textured surface, it's going to be a mess. But a smooth, clean surface is a dream. It's the exact same idea with images. Those complex, busy areas are risky, but the smooth areas, they are the absolute perfect hiding spots for our digital secrets. And the third and final piece of this puzzle is automation. The system just takes the amount of data you need to hide, and then it automatically figures out the perfect settings. You know, how aggressively to embed, which thresholds to use to guarantee the highest possible image quality every single time. So, we've got a smarter predictor, an intelligent selector, and an automatic optimizer. The theory is solid, but does it actually work? Let's look at the proof. This really is the moment of truth. How does this newfangled three-part system actually stack up against the best methods that have come before it? The results are in, and they are absolutely stunning. Look at these charts. In every single test, the new method, that solid red line, just blows the competition out of the water. See how it's always higher? That means for any given amount of hidden data, it delivers a much, much higher quality image. It's not just a tiny improvement, it's a complete game changer. And this wasn't just a lucky break on a few images. The researchers tested their method on 1,000 different images, and the results held up. It consistently delivered better quality, both in terms of pixel-perfect accuracy and just overall visual similarity. It's not just better, it's more robust and more reliable than anything we've seen before. So it's pretty clear a new champion in reversible data hiding has been crowned. But what does this kind of breakthrough actually mean for the real world? So what are the big takeaways here? Well, for one, we finally smashed that old trade-off between how much you can hide and the quality of the image. This opens up a whole new world of possibilities, from embedding entire medical histories into a single X-ray to creating unforgeable digital watermarks for art and media. It's a powerful new tool for protecting our most sensitive information in what is an increasingly digital world. This massive leap forward really leaves us with one final question to think about. In a world where our data is more valuable and, frankly, more vulnerable than ever, what new frontiers are going to require us to hide our most important secrets right out in the open?